Hello, welcome back, welcome in. Due to some technical difficulties brought to me by some Twitch viewer that decided to troll and make me uplift security on chat moderation, I realized I have a little bit too much trust for the general public. I haven't had any issues with YouTube or Kick viewers for that matter, but I've had a lot of interesting interactions with Twitch users. Not to say there haven't been a few. So kind of recapping back to before the technical difficulties, I want to work on and show anyone that's going into developing programming, as far as being a basic individual. And sure, you don't have to be basic on the sense of programming in general, but just the logic behind it, right? So we're thinking more of how to structure, how to use and apply certain techniques in programming that are related to mathematics. And if you have a basic understanding of math, well, cool. Well, a great place to start. If you don't have it, well, you're about to get it. So it's kind of like two birds in one stone, where potentially, if you've essentially gone through algebra 2, maybe you didn't pass with flying colors, that's all right. We're going to go over some concepts in mathematics that'll help individuals with programming, um, the concepts that lie between how to manage information, like variables, data, and most importantly, functions. And we'll go into object orientated as well, which generally speaking is not a very big necessity. It's just one of those recommendations to clean up and work with your code. So generally, you don't really have to use object orientation, but in the professional environment, it's definitely a must. But if you're coding for yourself, you're creating your own applications, your own work, it's useful to understand it, even if you don't apply it. So, where to begin? Where to begin? We'll start with what we did last time, going over just the parallels between your basic 15% of all languages, which includes variables, functions, logic, looping, and objects. Understanding how those work not only help you use other people's libraries of code, APIs, and other factors, but it helps you essentially work with the logic behind how to structure an application in a general sense. I was setting up a little workspace, workbench, if you will, for the stream that we'll be using on a regular basis. And we're going to continue from there, but let's take a look at these details here. So basically, in mathematics, you've got variables, x, y, z, LMNOP, whatever the case may be. I'm a poet, didn't even know it. But the reality is that they are just what I like to really consider any variable in the mathematical sense. If I can find the where did I put my pen? I had my pen somewhere. Now it's gone. Well, that's not the first. Let me use this other pen. So, damn, where did I put my pen? I hate when things just disappear. Oh, there you are. It's just a black pen on a black phone being camouflaged. When I think of any variable, let me see, kind of going over here. Let's say we say x is equal to 5. Before we even introduce variables to students, we started off as an unknown, which in essence it is, until we start giving you some plugins to work with. So when we ask the question, what is 15 plus something equal to 10, your brain starts firing trying to fill in that piece of information. This is just a logical troubleshooting method that the brain does. Trying to see, is it 1, is it 2, is it 3, is it 4? In fact, I should probably be doing a negative. I may make it simplified. I was going to do a negative number in there, but like this, just to keep it simple. We're essentially going to be thinking about, all right, what number can I add with 15 to get my 20? Well, that variable in itself, you can kind of plug in mentally, and it's going to be the number 5. So the way I look at variables is just a box of data. The X that we use in our vocabulary in the alphabetical sense of things, a symbol that represents a letter, And this is where a lot of students in math get tripped up, like what's going on? Why are we now using letters and numbers, right? But it's not like we're using them in the same format. There are some rules that apply in a mathematical sense because this X in essence is a box. It's a location of space, and we put a little label on this box, call it X, so we can recognize the differences between a box over here and a box over there. That box is X, that box is Y. We only label them to distinguish the differences between certain parts of our equation, especially when it comes to functions, which we'll see in a little bit. So when we think of any sort of variable, just think of it as a box of mystery, a mystery box. And when we state the directness of x equals to 5, we're telling you explicitly that this box contains 5. In fact, when you use x and any part of this problem equation after we've stated this little detail, it just means that this box contains the number 5. This is how variables work in programming. Although we don't necessarily stick with just the um, simplicity of a single letter variable, we basically use it in the form of let's name something specific so we know how to access that thing in the future. So this is where we go over here and say, all right, in programming, you can use x equals 5 if you'd like. You can also use number x or num x to specify. Or if you're not even using numbers, let's say the color of a specific character, you would use hair color. This would store the information. So we're kind of dealing with a sense of different data types. In math, we've only got numbers as far as data, as far as usable factors. But in any other format in programming, we obviously have way more than just numbers, including decimals and integers. But we have true and falses, what we would call Boolean. We can call it Boolean value and then call it true. Some languages use capital T, some use lowercase t. It all really depends on the language you're using. But the fact is that it wouldn't be any different than saying Boolean number equals to 1. They bear the same results because if we really reach back to the focus of how a program even works, it's zeros and ones. It's all the way back to something turning on or something turning off, all the way down to the basic components of a circuit board. A specific path is judged by where all the ones are, and we're just following that process to get to the end result, which is turning on the device or turning it off. So we kind of simplify this idea where 1 is true, 0 is false. Hello, Harshit Tamar. I'm going to be going mostly through a JavaScript centered, but the format in JavaScript is, I like it personally because it's the least amount of um, setup for anyone to get started, and because you can basically run it in any sort of browser. You don't have to install any SDKs, developer kits, and runtime environments and compilers. So I like to start with the concepts in JavaScript, and this is how I normally start, even with like 10-year-olds. I actually taught a kid uh, at 10 how to use JavaScript, and then we went to Lua in Roblox, and then he came back like a couple of months later and was showing me how he learned Bash scripting, which was super odd and random. But that's the key, right? Once you understand one language, and he really took that to heart, you can learn anything else within the same bounds. Just the format changes, the syntax, the way we essentially use the words and the language pieces together. And that's really where I was focusing on the first view here. In any sort of sense of a language, English, Japanese, Chinese, Spanish, you're looking at two forms, right? You've got vocabulary, which is what we would see in a dictionary. You open up a dictionary, you start reading words in a different language. Can you use that language? No, you just know the words and you can try and put them together in some way, but it will be no different than a monkey trying to type on a keyboard, trying to make a story, right? You eventually may get to the right set of combinations to make sense, even so slightly. Not that you would know. But the next step is not only the vocab that we would normally use within mathematics. I would always consider this to be memory. If you ever wonder how to learn math, the first key is where can you apply certain strategies to learning? If it's a vocabulary type memorization, flashcards. Just, one flashcard side equation, other flashcard definition. But just because you're memorizing the dictionary doesn't mean you can actually use that particular equation or word or dictionary entry. What you would do is you would learn the next other case, which is syntax. And this is where languages differ. Mm. So while the dictionary between different languages like Python, PHP, JavaScript, Java, C++, all of those may be essentially similar, printing something out, gaining an import. The dictionary may not be obviously mirroring each other. The syntax stays pretty consistent. The syntax would be just the way we follow and put those words together to make a sentence like I'm doing right now. I'm not even thinking about it. It's almost instinctive for me to speak in the language that I was given to me or taught over time. But I mean, that's why I kind of like a mathematician. I like to teach mathematics to my students. If you told me, hey, teach me English, like we can talk and communicate, but I'm not going to be able to be like, oh, I said this way because of this particular rule on this paragraph and this. I'm just not an English teacher, right? So I can speak and help with the structure of someone's speech based on how I reflect my own language, but it doesn't mean it makes me a good teacher to use something versus to being able to understand it to such a way that it would be cleanly expressed and learned. So that's why I like math. Math is very structured and I can always go back into my general way of understanding it. Back to this point, right? The syntax and the vocabulary. Now, in mathematics, you may have heard of it. The syntax is PEMDAS in its very general sense, right? So we've got parentheses, which is a very important factor in any sort of programming language. So there is a certain criteria or importance of whatever is inside of parentheses. In programming, it's a very similar case, and notice this here in our example from before. When we're looking at alert, there is a set of parentheses that is explicitly talking about this alert. It is attached to the right, therefore it's associated with something called alert. Function itself here, which we'll go over in detail later, because we're still kind of taking stepping stones forward, expect something. You're trying to input a value into this particular function. So the parenthesis acts as a container space. Hey, whatever you put in here is going to be passed along to this particular function. Now, this wouldn't be any different if we can now start expanding into um, functions in general before we go into full detail. This alert example isn't any different from a function in math. We know the infamous f of x. And let's take a look at alert of, let's say, X. Okay. Alert X would be a JavaScript specific function to basically make a little pop-up come up and talk to your user and troll your friends if you put it on a loop and then they keep trying to press OK and then it just keeps popping up and it can be used for good and bad. Any power requires absolute responsibility. And as per the previous stream, if you saw that, at the very end, I had an interesting Twitch streamer who decided to abused my trust for the public and gave me a link that would basically do similar things. It would make some pop-ups. It tried to access some things. It did overall mess me up a little bit, but because I have my Windows system partitioned into multiple locations, I've got about two firewalls. I've got a bunch of anti-spyware, anti-malware. I was able to stop it before it did too much harm. And when I noticed that something was wrong, I just had to refresh my Windows system. And because everything is basically organized in different partitions, I really just had to install Chrome and I was done. Because all my games are on the second partition, all my files and stuff on the third. A little bit technical there. Maybe I'll go into securing your general sense of the system in the future. So thank you. Appreciate that, Sarkar. So if I butcher your names, please have mercy on me. There's gonna be so many types of people coming up. And honestly, I've had way more great interactions with YouTube than I have with Twitch. So I'm almost like this close to just really restricting Twitch from even existing on my chat. And based on just general testing, I've noticed that Twitch viewers like gaming better, which is cool. But every time I do anything educational, it doesn't really catch the interest of a Twitch streamer. I guess they're there for a specific reason. So either tub streams, hot tub streams or gaming, or probably the latest one is gambling. So unless I'm doing one of those three, I don't think I'm going to be really doing Twitch too often if the abuse of the chat continues. But I have upped the moderation, so it shouldn't be an issue. Anyway, back to the process. So an f of x case, right, a function in math and a function in code. And again, it's alert. It could be printf in C++. It could be just print and print ln. There's so many different formats of it, right? But the case scenario is just we're just using this JavaScript situation as an example that's related to math. I did use Brave. I did use Brave. I absolutely used Brave, and yeah, it's still like it didn't load up the page because I actually went into a website that everyone should know about. It's called any.run. If you go to any.run, it's a website where you can actually input a URL on the web, especially if you know it's malicious, and it'll create a contained environment, run the whole thing that's supposed to happen, and even list to you what that virus or injection or whatever it was trying to do. So how it happened was, interestingly enough, talking about Brave, Tor for sure, Tor for sure. I should have just considered, hey, maybe don't trust this person's link, but Tor would have probably done a better job because it restricts JavaScript overall. But what had happened was I used Brave. I went to that link, and sneakily enough, it had just enough of access to my terminal, to my command prompt, that it hate Edge. I hate Internet Explorer. It's almost I don't know why they continually push it, especially with the fact that what happened here was they bypassed Brave overall. I noticed that the page didn't load up completely like it should have based on what I saw during stream versus what I saw on the any.run website. And I noticed that like it opened up some injection to basically bypass Brave, go into my command prompt, and open up Microsoft Edge. And the first thing it did is it went to the same link that I went to on Brave. So not only did I basically use Brave to overrun or over walk around this exploit issue, but it was able to somehow briefly for a moment go into my command prompt and just open up Edge anywhere, anyway. So regardless, it seemed like Brave was just good enough to maybe not spread the issue on the browser, but it still ended up well activating Edge in the background. So from now on, I'm basically deleting all Edge components. And I know it's going to come back with Windows updates because they don't want to let that go. But I'm going to continuously, essentially factor that into the equation. Every time I see an update, I'm just going to check that stupid Microsoft folder. And I'm thinking of a way to somehow maybe make a fake placeholder file for Edge. And I can just replace the whole directory with that particular placeholder. And then maybe restrict Windows from changing it. So then if it tries to update, it won't basically do anything, and it'll just be a empty file called MS Edge or whatever the hell. Anyway, fun fact. Edge still is a exploitable factor even if you're using other browsers. Fun fact, right? So be careful. Don't be like me. Don't trust the public. I mean, I know this for a fact. I know I shouldn't trust any chat that spams out, but they were like, "Oh, look, I made a Flappy Bird game," and I literally showed them my own Flappy Bird game called Mathy Bird, a little application I made for my students to basically get used to practicing math and having fun. And I was like, "Oh, cool, that's relative." That's how you get them, though. That's how you get the just 1 millisecond and one false move and one little sniff of trust, and you can breach anyone's well, social engineering, right? Anyway, away from that, going back to the functions themselves, in mathematics, we have an input, okay? So we have this input value in our parentheses. Now, this is a little bit of a different factor than the PEMDAS parentheses that we would see in equations, but there is also a sense of a double system of work here. In the case of PEMDAS, there's a priority involved with anything inside of parentheses. So whatever you see in parentheses, you should do first, and then you'll focus on any exponent values. And then, well, let's just call it number squared. And then you're going to focus on multiplication. This is why I wanted to do number squared, because multiplication is in x, and it can get confusing. Division, addition, and then subtraction. Okay, so these are factors of we read books from left to right. So we apply these operations from left to right. And in the case of applying these operations, we are just doing what we see in that order. And there's some caveats to it. You can add and subtract in whatever order you want. Normally, you can divide and multiply in whatever order you want. Some case scenarios, not so true. So I would normally just do left to right with multiplication division. But it doesn't matter if you do 10 minus 5 or negative 5 plus 10. It's the same answer overall. So there's small caveats, but the overall case is that you're just reading from left to right. You're remembering PEMDAS. Please excuse my dear Aunt Sally as a acronym if you need it. But you're just following these sort of forms of which one you do first, second, third, fourth, fifth, and finally sixth. But in the case of functions, this is what we would call a singular object in math. This is one object. It's not f and then x. It's not two things that are multiplying. That's the very big misconception when we first start understanding what functions are. It's not f times x, it's actually f of x. There's a factor of f is a function. It's a whole built out structure, and x is going to be plugged into that structure, right? So in this case, we can have something like 5x minus 2 as a linear function. And of course, in this case, you have quadratic functions, you've got trigonometric functions, statistical functions. The variety keeps going depending on which class and what dictionary you're reading, right? So each class after algebra would be the true syntax, and then everything after that, calculus, trigonometry, statistics, differential equations, everything else is essentially just maybe differential equations might be just a little bit extra on the case of applying algebra in an advanced sense. Everything else, as far as classes after algebra, they're just dictionaries. They're just learn this equation relative to statistics, or learn this equation relative to trigonometry. And then you're applying still the algebra, which is the root of the syntax, how we would use mathematics, and you would apply it to trig or calculus or statistics, right? But the issue is I have a lot of students that come to me, or at least when I used to work at Valencia College and University of Central Florida, they would really think that calculus was the problem or trigonometry was the problem. The class itself in which they were standing was the problem overall. It's really difficult to do calculus or it's really difficult to do statistics. The problem every time, however, is the misconception of what algebra is and what calculus is. They thought just because they were enrolled in a calculus class that they would struggle with the calculus specific details. But every time we sit down and we go through the process, it turns out there was something in algebra that they forgot about. Or maybe most of the time, there was a teacher that absolutely sucked and they didn't teach as well for that one particular chapter of exponents or logarithmic functions specifically. That's a big one. Maybe the teacher didn't understand logs in general and then just kind of gave them all the general syntax properties and is like, all right, now go, you can do it now. Like that's not kind of how it works. You have to be very detailed in your understand or of your outputs, right? As a teacher, you have a set of outputs that's coming out of your mouth to teach students, and unless you thoroughly understand it, your outputs are going to be gobbledygook. They're not going to be understandable, and they're just not going to make sense for a lot of students. Maybe it's just enough for them to finish that problem, but then you ask the student how they did it and why it works, and they're like, I don't know, I just followed the teacher's instructions. I hate seeing that. I hate seeing that. I hate seeing a student that was given information from a teacher and they cannot explain why they're doing it. They just said, my teacher did it this way and it's always worked. Therefore, I'm just going to keep doing it. That's really how education has become because of a particular factor of cookie cutter, right? Everyone's got to be learning in a specific way and a specific standard that some students that learn visually or kinesthetically are not going to adapt to a student that learns auditorily through listening or through replicating mimicry. So, because we all try to basically PowerPoint our education, a lot of people get left behind. Ooh, excuse me. One second. So, in a mathematical function, we have f of x and 5x minus 2. I always love color coding because when we're looking at this, we're looking at X being the input. Whatever we plug in, remember that concept of X is a box with a label, right? So we've got some box with a label called X, and we're dropping it into our function. What happens there is whatever we say X is going to be, like maybe equals to 2, that gets transferred, that gets connected, and it goes all the way into where we would see X appear within the definition of our function. So we essentially carry that data over, and whatever appears within the function of the object of in parentheses, we carry it into the location, and it can be one location, it can be 10, it can be all over the actual equation. It doesn't matter how many times we see X. All we know is when we say X is equals to 2, everywhere we see X as a value, we plug that value in, right? So in this case, just linear equation is once. Same exact concept in functions. Functions, well, we don't have equations, but we can arbitrarily consider a block of code to be our equation. Everything within the typical standards of programming has curly braces to organize certain blocks of code. The blocks can do a plethora of things. In fact, we can have a function like alert. We're not defining alert. But let's say we have custom function. Uh, I guess in JavaScript we would define it as function. In Python we would say def for define. Python has slightly different syntax. That's why I'm not going to use that too much. But in JavaScript, we would use custom function and then some variable that we are inputting. Again, doesn't have to be the name of that particular variable. It doesn't have to be X, Y, or Z. It can be a totally custom thing we make. And then from there, we have these little curly braces. That's horrible. That we would use in a format like this. That's horrible too. It looks like a face. Hold on. There we go. Now, I don't necessarily like doing it this way because it's like, all right, there's this whole space in between what goes in here. Well, obviously, the code of our equation, our function will go here. So I like to generalize every single block of code that I ever see in any language, right? So let's remove this. Let's go back a bit. Let's generalize this format and use this format. We know we have an input, and we know we have a block of code. Where else do we see this format? Basically everywhere. Everywhere that's not a single line of code. If you ever recall, if statements, they have this format. For statements, they have this format. In fact, one can arbitrarily say that those are actually functions that exist at the very root of the language. They've been created once upon a time in some galaxy far, far away, and they've never changed. They've never been updated. If stays if, for stays for, etc. Right? So that's the key there. You have while functions. Heck, you kind of have even class definitions, objects. Object, I would call a object blueprint. If we ever go into details on classes, always think of the class creation part as a blueprint. It doesn't exist. You're not making it happen. Custom function, I've created this. It's just basically abbreviation for me to say a custom function I've decided to create. That's it. I can name it anything I want. I can even name this X or something, some funk, right? There is a key to understanding where the differentiating factor of what exists in the language itself and where is the point where I'm creating those functions myself. So recall alert, right? Alert in itself is an existing function in JavaScript. If I go back to my little browser here, or really my code, and then I open this sucker, Reveal and Explorer, open it up in my Brave. Hold on. Or AVG. Oh, there we go. That's fine. Maybe the alert doesn't work in Brave in AVG. Normally you would see a pop-up happen, but I guess AVG has that part locked down pretty well. So maybe I should have used AVG for that factor. Huh? That should have happened too. Oh, I didn't save this? Hold on. Hold on. My keyboard is in the wrong computer. Luckily, I have a multi-computer system set up right now. Give me a second. All right, so I had to save this. Then I refresh it. All right, there we go. So there's the alert at work. This is what happens when we have an alert begin. All right. The alert function is built into Chrome. Somebody created it when they created the Chrome browser. And this is what we call a existing or I guess a root function, not even a root function, a out of the box function. Whenever you're using any language, you have a set of functions that you're given. In fact, there's another one that's kind of obfuscated inside of something called console. Here's kind of an object that exists, right? The console is actually now in blue. Blue normally in JavaScript means that it's a object that has a lot of stuff inside or other functions or aka methods. A little bit of a difference in language, but they serve as the same thing. And then I can do to console log. I keep doing that. And I haven't touched or created these functions. These exist solely from the existence of the language itself. So I've saved it, I refresh, there's that same alert, but you're not going to see this console log here. You would have to go to inspect and check out the console in inspect. That's just a way for us to take some information from our program. We can plug in variables in here too. If we're trying to figure out what is this variable doing right now, well, we can plug it into a console log or an alert. I wouldn't recommend alert because alert just keeps on popping up all the time. It's more intricate to post any debugging. This is what we call debugging in the sense when we're trying to figure out what's happening in our variables in our program. Because again, variables are boxes of data. They're not just a number that exists. Like a number 5 is going to be 5 forever. We use variables because we can change it from 5 to 6 to 10 to 1,000, whatever we want. All the menu items or option items in your game are variables. Brightness amount. Brightness equals 50%. What if the user goes in to the options and changes that from 50 to 75%? Well, the variable now has 0.75, and whenever it passes through the settings, configurations part of the program, the game, it'll change the brightness to 75%. So if we just and that's kind of a big difference too, hard coding numbers into our program, it makes sure to never change. It's always going to be, if you're a bad programmer, like one of the indies, sometimes you see it in indie games, and you go into the options menu and you're trying to change stuff and nothing changes, that's probably because they probably put an actual number like zero point 0.5 at the brightness. And when you change it to zero point 0.7, there was no variable to control that change. So it's always going to be zero point 0.5 and the brightness never changes, right? So then you disconnect from the user interface where it's looking to adapt that variable, and that's why we use variables because they are changeable by definition. They are a box that exists that can be modified through our code. But if you just write zero point 0.5 or brightness equals zero point 0.5 and or not even, because in the sense having brightness equals zero point 0.5 is saying I'm putting this number inside of a variable called brightness. If you have some function somewhere that's changing the brightness of the screen and you just put zero point 0.5 in that function, it's always going to be zero point 0.5. We got to go into more depth of how functions and variables start to work together to become more dynamic. So when I say some func or custom func or whatever, all I'm doing is general consensus of programming. You will gain this new way of learning, not learning, of reading how coders work or how coders type things. Um, Normally, there's a case where, let's say I have username. I want to take username, and this is the idea. So this is kind of like your pseudocode. I want to take username and set it equal to Chris. Right? Or I want username to be Chris. So you would take a pseudocode idea and say, all right, how do I make this happen in actual language? Well, when we're actually coding, we cannot use spaces like we do in regular language. What we would do, however, is we would remove any spacing we would normally have in that language and say, all right, the way I can translate this in JavaScript is var. I want to create a variable. I'm going to name my variable appropriately. but I'm going to name it this way. And this is kind of the camel case, right? This little hump in the name or in the word. So instead of using spaces, because programming spaces mean a specific thing of separation, and you can't really have spaces in the names of anything. You can use underscores too. I mean, there's another case. It really depends on the specifics of the developer. You can also use user underscore name. This is more of a slug format. If you look up slugs, especially in WordPress, you see this happening all the time. Anytime you as a user puts in information, and then it has to like maybe a category of types of shirts, blue shirt, right? The program will take blue shirt in sentence, and then there will be something called slugify that you input that, and then the output. So input here, the output would slugify this word, and it'll make it into blue underscore shirt. Because now this is a format that we can use within the program. You can put this in a dictionary list. So if you have a set of or a key value pair with more variable types that we have to go over, but basically we can put this in a type of array of clothes, and we can put this as blue shirt because now it's programmable. This sort of format is programmable and readable by the the code interpreter, the compiler, whatever is reading your code specifically. So we don't necessarily use the name or the full sentence. We would speak as a human username, right? We would say, I'm going to change username to a either slug or a camel case. I'm doing it all the time because my preference is camel case because I feel like it's a lot easier to read and it's cleaner. So camel case, and I would say equals, which would be kind of a key for to be, right? To be is just a equals, and then put Chris. And that's how we would translate something that would be considered pseudocode, an idea that we want to. Oh, thank you. Thank you, thank you. I have been writing, and none of y'all except Kumo here was the one that noticed it. Thank you, thank you. Right, okay. So the explanation hopefully was good enough without the necessary need for the drawing. But I do go back and forth enough, and I get distracted by ideas, especially when you guys mention something I want to show it out. But here's kind of the key for pseudocode. You can convert these in this form, whatever floats your boat, really. And that's kind of the perspective. What is in programming my personal take on what I can create and how I can customize it, like username, versus what exists in code that I have to use in a specific way that was already created, like alert, right? So the console log shows the same sort of concept there. So when we're thinking of, hey, there's a sense of me influencing my own language into this program, it comes in custom function names, it comes in custom variable names. There are some variables that are defaulted and used by the language itself, but you won't come up to them very often, and you'll get an error saying that this variable name is a system resource or something that you cannot use. So the variable names normally are much more flexible. But in the general sense, you have the ability to influence the way that you structure and you name your own code. So that's where custom function comes in, or in our case here, some function. I had this before. I didn't really use, I guess, camel case. I kind of did because my functions, my F looks like a lowercase sometimes and an uppercase, so it's a big back and forth. So that's the idea, right? We've got custom things we can influence, we can change, we can modify, we can call whatever we want. We can just say X for the function name if we wanted to. But in the end, if you just keep coding with such an arbitrary and not so structured form, you're going to go back in your code. And there's a story behind this, like mine, back in computer science class. you're gonna go back in your code and be like, what the hell did I just write? Where is the thing that changes the other thing? And you just have X's and Y's and P's and maybe, oh, I ran out of X's. Now I gotta do X1 and X2 and X3 and X4. Fun note, you cannot start variable names with numbers for the obvious reason. Because a name normally is involving a variable letter. So you can kind of say custom function one, but you cannot say sum function. You will not be able to put numbers as the front of your variable name. But at the end, it's totally fine. You can do that anytime you want. Now, it's the awareness, right? It's the awareness of when do I know what exists and when do I know what I have to create myself? Well, when you create something yourself, you're just taking a set of steps that you see you're doing a bunch of times and saying, hey, I'm repeating this code all the time. I can put this in a function and make it super easy for me just to call that set of code block, right? We always have a set of blocks of code right here in the curly braces. So the sum function calls that code, or the function that I create specifically is for us to create a custom set of code that we are going to repeat on a regular basis. Uh, for if, well, they have a special usage for if. So if we cannot really modify, but we use if as a logical choice maker. If something happens, then do this. But if it doesn't happen, don't do it or do something else. But once you see that every single kind of structure is similar, it's a sense of the name of something, and then you have a set of inputs, and then you have a output. Oh, wrong color. And it just follows that flow. You have an if that already exists, so we can't really modify, but it is still a name of something, right? And then you have the input values of whatever that's supposed to do or was supposed to check. As far as logical, in this case, it's checking if this situation in parentheses is true or false. And then we do something based on that situation. The for loop, well, it's kind of a little bit extra here for the if. We'll have to go over the details on it, but it's got a bit of a logical structure where we're repeating something X amount of times. So for this case scenario of X is less than 0, or X is less than 10, but we're going to make X start at 0, and every time we complete this code block, we include X is now going to be a plus plus. In certain cases, it's a shorthand. But if you know mathematics, here's another one for you. If we're thinking for loops, there's always this weird thing we have, X plus plus. What does that mean? Well, that's another way for us to say, I want my X value to change, and that change is going to equal. It's a weird only case reversal of the logic that we're normally used to. A program runs top to bottom, left to right. Okay, right? That makes sense. But then this case scenario is weird because now I want X to be equal to whatever my X was a moment ago plus a number now. 1, 2, 3, whatever you want to increment by. So this would make if X is equal to 0 initially, and we go through that loop over and over, we're just going to make X start from 0, and then the next loop it's going to be 1, then it's going to be 2, and then it's going to be 3. It's a weird sort of twist because what it's happening is it's taking the previous value, adding a 1, storing it back in X, so it's not really a left to right situation anymore. That's the only tricky part about this. So it's taking the previous value of 0, adding 1, and then spitting it out to the next reoccursion, reloop, and then from there, now we're going to have the next increment. So the next case, the second time this loop runs, X is going to be 1, and then we're going to be adding the another 1 to it. So we're going to be adding another 1 to it, and then that's going to make a 2 pop out. So we'll go into more of that sort of mentality, but this is kind of an interesting twist of programming. I am able to think the solution of LeetCode contest, but not able to code it. Likely approach is 90% but I'm not able to code it. What should I do? If they have the like my approach is 90% correct. So let's kind of take a quick question here from Jay. I'm able to think the solution of LeetCode. Potentially you got the solution without using, because okay, you can code anything in multiple ways, right? So I can, and depends on what the problem was. I can print out, if they say, hey, print your name 5 times. This is one way, basically a copy and paste approach. Like line 1, print Chris. Line 2, print Chris. Line 3, print Chris. Print Chris, whatever, right? But then they may not be looking for just copying and pasting it. They might be looking for you to understand that you can save, again, instances of um, lines of code or efficiency and say, hey, for, here's kind of our example of the for loop, x is equal to 0, starting at the fact that x will start at 0. I will make my x move up until it gets greater than 3. This is your inequality that happens to be a mathematical factor here. And then I want my x to equal x plus 1. So now that we kind of see the logic from the um, previous situation, this is how you would code it in a for loop, right? So this is where like the for loop is a little bit extra, like thinking about that conditional input. But this input's basically defining how we're going to be running it. And then I can say, all right, now I have a loop that goes 3 times. And to keep it simple, I'm not going to go to the next line. I'm just going to put my block of code here and then put print Chris. And this, in essence, will achieve the exact same thing 3 lines of code will do, but in 1 line of code, with the general arbitrariness of the block of code, which can be spread into 2 or 3 lines. But if we do it this way, we've saved 3 lines of code with one single line. And this is kind of potentially what's happening. You've got the right answer, but your approach was slightly different from the most optimal way you can do it. And being in leak code, you're kind of looking for that most optimal path to include it. And this is also a case for mathematics. You can solve math in many different ways. That's why a lot of times students solve things in different ways. You have a student that will get the answer right, choosing a different path than another student that got it right. In fact, many times you look over at your friend, he's done it the test 10 minutes in, and you're still doing the same problem, or problem 2 or 3 out of 10, and it's been 15 minutes. How did he finish first? Well, the mathematical sense of the process there is that maybe he caught on to a step that reduced the amount of work he had to do. And as a mathematician, I always tell my students, mathematicians were lazy. We never want to use huge numbers. We change negatives to positives whenever we can. We try to make every single step, even if it takes one extra little detail in the very beginning, to basically give us less work to do. We're lazy. It's the think or work smart, not hard mentality. That's what a mathematician aims for. So in this situation, yeah, you can print out Chris multiple times, but that does not mean that it's the most efficient way. So maybe you got the final leak code answer, you're just missing some little detail that maybe you have to optimize this, or don't use too many variables. That's another one. Or reuse the same variable over and over without creating a new one. That's a big case for efficiency. Every time you create a new variable, you tend to start using more and more memory, and it just kind of bogs down the system. Or if it's a more advanced problem, delete the variable or free the memory after you're done using it. It could be another situation. So it really depends on what lead code problem you're doing, but it just means you're so close to being there. You just have to analyze your program, read the instructions carefully, and just make sure your instructions, your processes are abiding by what they're asking for. That's it. It's basically follow the instructions. Something in that 10% that you didn't get was kind of missing, right? So that's a big piece that you want to keep an eye on. All right, so back to our general structures. Glad that we can go over at least the for loop, but we do see now there is a pattern with each of these. And we can say one thing's for sure, these formats are built in. We cannot customize them, we cannot change them. We learn how they are and we start using them. This is the case for vocabulary. So when we're thinking of programming in a general sense, it works the same way as a spoken language. You have a dictionary of words, you can memorize them all you want, cool. But then when you start using those words, you're going to make sense of the way you use them. So this is us learning the words. This is us respecting the syntax of those dictionary words. So, kind of bringing it back full circle, we're thinking all languages share the first 15% of context. The things that make every single language, Python, Lua, Java, JavaScript, PHP, I think I used my thumb twice. Uh, every single language you can think of has variables, functions, logic control, looping, and objects, which we haven't quite done yet. So then you're like, well, where's the other 85%? Well, what do you want to do? The 85% for the rest of the things you want to learn is going to deal with, are you a game dev? Are you a data analyst? Are you a web developer? Are you trying to create apps on an Android phone or software on a computer? Right? Those are what we call the library. So you're not ever going to reach 100% here or all 85%. 100% of 85 is 85. So you're not going to completely take all of this extra library of 85% and make it yours unless, you took, I mean, unless you're extremely, I don't know, persistent on learning every single thing. It wouldn't be necessarily useful to know everything. If you're a game dev, maybe 10 years, you'll learn everything there is to know about it. There is a case for like I wouldn't even call it 10 years. I mean, here's an interesting math situation, right? You want to be professional in something. Well, they say it takes about 10,000 hours to be professional. Okay. 10,000 hours, right? Where's my calculator? So, how much is 10,000 hours? Well, 10,000 hours. We've got, we don't know how many hours in well, 24 times 365. So let's take 10,000 hours, divide that by 24 hours per day times 365 days. You can be a professional in 1.14 years, man. But you know what? That means you're not sleeping. You're probably dead by the first month. So is that feasible? No. It's absolutely not feasible to be a professional in something in 1.14 years. So then we say, all right, what if I sleep half of the year, like kind of like double it, right? Because you're not even half the year. We all sleep about 8 hours. Sometimes for me, it's like 4 hours. But what if I kind of have sleep involved and then work involved and all these extra values involved? Well, we might study 15, 20% of the day. We might work 60% of the day and we might sleep the other 20, 30 plus eating plus resting, right? So if we think of, hey, how much would this be in the case of like if I spent 15% of my current day of this value studying, we divide that by 0.15. It's going to take you about 7.6 years, feasibly, if you're really grinding it, right? If you only spend 15% of your day, it's time that 3 jobs, yeah, by three. If you have no other job, yeah, yeah, yeah. You time that by three. But again, if you're spending like 15% of your day, yeah, if you don't have like two or three jobs at once, man, nowadays it's been crazy. Um, let's talk about that. You've got AI taking over, but in a way, it's also a tool. So it's always good to have. It speeds up a lot of developing, especially if you're starting to learn. I mean, I don't know if I've shown, I do have an AI setup, right? So you can look up how to create a, AI setup. But here's what you can do, like just with AI to benefit yourself. Because I know AI is going to be like the biggest culprit that basically is going to take everyone's life away. But if you have something like, oh, do I not set it up yet? Oh, crap. Hold on. No, I had to reinstall my system so I didn't set it up. Basically, you can use Olamo to set up a local server, right? Let me close this little window down. And you can use AI on your computer as long as you have at least like a graphics card. You can still use the CPU, but man, will that take forever to process. I have a video on how to set up Olama. Um, Let me see it. I hate YouTube lately. It's been a punk. So if you find my no DeepSeek, oh, I think it was a DeepSeek video because you can do DeepSeek on your computer too. You don't have to pay nobody for nothing. So here's a share. No, I gotta go posted places. Uh, but I'll do it on YouTube because it'll be quicker for now. So you can essentially take that, use that to set yourself up. And what you can do is you can create at least, hey, show me how to create a function properly, or show me how to work with objects. Make a player one and the player two fight each other using class objects, and give each player health, give each player attack, defense, accuracy, and all these extra values, right? So with that in mind, you're really taking the idea of a AI to help you create something, and you can even get some code, give it to the AI and say, what's wrong? Why isn't it working? All these debugs. Because I didn't mention before, the biggest issue with working with any, absolutely any sort of code, in my computer science courses, it took me about 1 hour to make the code. But on top of that, it took me about 7, 8 hours in the beginning figure out why it's not working. Right? Because what I would do is I just type everything out, get it done. I want this to happen. I want this to happen. It's almost like pseudocode in the coding space. And you would eventually realize, holy crap, I didn't check for any bugs on the way. I didn't stop for a moment, use a couple of prints. I just basically went all the way through and decided to just, you know, YOLO my code. So it took me 6 to 7 hours to go through and be like line by line. Okay, print here. Is this printing? Yes, it's printing. Print over here. Is that printing? Oh, it's not printing. Something broke before that print happened. So now I got to look between the two prints where it worked and where it didn't work. Yeah, a step-by-step approach. You got to make sure you're debugging step by step. That's why testing is important and good air practice. It's a kind of it's a lost skill set, I feel like, to be able to, I mean, because again, you're reading errors coming from a computer that can be like, oh, here's the line it's on. Cool, that's great. Give me the line and I'll figure out the rest. But because some people, some students especially, haven't experienced enough error to see or decrypt what the errors are. Especially, don't get me started on C and C++ and C Sharp and Java. Those errors can be sometimes so encryptic that you're like, what the hell is happening here? But many times it's not the error in your code. It's like your code having a variable that gets passed to a function that gets passed to a class that's created by the Java API, and the Java API is trying to tell you, hey, you did the wrong thing. You put the wrong variable type in this variable, or you put a string when it was supposed to be a number or a Boolean. And then it has like 5 or 10 different lines, and it's showing you line 10, but then it's also on line 11, but then it's also on line 12 and 13 and 14, but it's one error. That's because that variable that was an issue in the beginning was passed through all the other types of classes, and you ended up looking at it like, which one's the actual error? So the best case is to start at the top beginning and potentially many times going at the very bottom and seeing if the bottom is going to be the one. But if the bottom is like a function you've never heard about, there's no reason to go into that function. You go upscale backwards and say, all right, did I create that? No, that's an API. Did I create that? No, that's also an API. So you keep going down to where it's familiar and say, oh, I made that. I must have just accidentally not put quotes around my one. I wanted it to be a string, but I accidentally made the number one as a integer, right? So those are the case scenarios where when you're debugging, it's not fun. I know I'm losing people watching now because I'm talking about debugging and not talking about programming. But in the end, if you want to be a programmer, you have to know how to debug. You have to essentially turn on that troubleshooting. It's like detective work, honestly. It's like detective work against yourself. Once you see, because here's how a hacker works. This is essentially why this hacks exist. When a hacker tries to exploit something, you know what they do? They dive down to the developer consciousness. What are the biggest mistakes developers do? Off by one. They forget to clear out memory. They forget to reallocate resources, and they have a huge array that eventually got smaller, and they didn't change the memory size of that array. So now you have a big old chunk of space that they can inject their own code into. When you're debugging and you're fixing your own code, you are not only improving your code, you're improving yourself. Like it's deeper than that. You're being more self-aware about the mistakes you make as a developer, like as a human being. And then you're trying to say, all right, I know I keep making typos. I need to be more conscious about when I put a capital and when I don't. So debugging is not just, oh, I got errors, let me go check it. A computer works exactly as it was told. So if you're telling it bullcrap, you're gonna get bullcrap. So it's many times that a person is so like kind of stubborn about the way they code and the way they want to do their own thing that they hate programming because it never works the way they wanted it to work. But that's not the point, is it? The point is the computer just follows instructions. And if you're giving it shitty instructions, you're going to get shitty outputs. So bettering yourself is also going back to the things you've created and double checking your own work. Leave comments. Give yourself a little bit of a step and something that you can control find really quick so you can move around your code a bit better. But never say that it's not my fault this program doesn't work. Because there's no other reasoning for that. A computer works exactly as it was intended. It reads everything as it would read it. And as soon as you make a mistake, whether it's a capital to a lowercase, whether it's you forgetting to make an actual like uh, freeing of memory in C and C++ from malloc, memory allocation, any of those factors, not only if you're a professional programmer, that should be your number one cue, is that you need to, you know, you need to put them boots on and start really taking things seriously. Because if you're affecting a bigger program, this is probably why programs are hacked all the time now, because no one's taking into account their own particular weaknesses as a developer. So what does a hacker do? He has a set of weaknesses that they know that exist within majority of programs. Now with GitHub, that's the biggest give off. You find on GitHub all the issues people have when they're doing, and then you jot them down. Oh, this person forgot memory alloc. Oh, this person forgot memory alloc. This person's off by one. This person's this and that. And then you get the big tally of how often an error occurs. You've got a statistical sample point. Now, if there's so many people forgetting memory alloc, you know what to exploit because it happens so much in GitHub because it's the open world of code. You can see what the masses are messing up on, and that's a statistical representation of what the general world will basically mess up on. You're not in a bad place, Baba Yaga. Nice name, by the way. Your Mac is fine, but you would have to really dive down into the terminal level. Even then, you're kind of locked out behind some stuff. I wouldn't say no, you're not dumb, obviously not. Mac is actually closer to like a Linux Unix based system, so you can essentially run similar things between it. Your only issue is you're fighting Apple. You're fighting the limitations Apple is doing for you. Um, there are security factors that you have to work around when you're doing exploits. I mean, the case scenario is trying to figure out how to access memory, which it's a Linux system, so it's probably a lot more locked down, especially being Apple. So reverse engineering certain things in Apple might not bear too much fruit. And if you're trying to reverse engineer anything nowadays, I mean, sure, 20 years ago it'd be much easier, but nowadays everything's hooked up to the internet. So if you're trying to reverse engineer anything, that program that you're reverse engineering is probably making a callback up to some other server and saying, "Hey, I'm a legitimate software. Here's my key." And if you're trying to reverse that, it's like, "Oh crap, someone's messing with memory. Shut me down." There's just this huge telemetry factor nowadays that reverse engineering software, unless they're kind of isolated or unless you find a way to make a software work outside of a connection. This is also the issue with games. Why do you think everything is interconnected now? You want to go into assembly. You want to be able to go into assembly, read, disassemble, find a disassembler, use the disassembler, understand where basic programs work, get a calculator on your Mac, disassemble it with a disassembler. I'm not going to give you the specifics on what I use as a disassembler, but you want to disassemble a basic program into assembly, which is going to include a bunch of movements, a bunch of different registries. And once, I mean, if you do it for a Mac, it's going to be different for a Windows because at that level, you're going to try and look for something that would be interchangeable between the systems. But because a Mac processor is different than a Windows processor, is different from the ARM processor, what you do on a Mac, this reverse engineering level, it's not necessarily going to work for the same other systems. But memory is normally pretty universal. So you would use a disassembler, take apart like the calculator on your computer, and then look at how it works. There's ways where you can take steps like calculator loading. What line is that? What is it pulling from my information, from my file system? You would look at all the memory allocations it does, And from there, you want to read that stuff, which honestly, I don't even know too much about because that was kind of one of my biggest keys is to be able to read this assembly or assembly language. But it's just not feasible, at least for me, since I'm not going to be using it. But if you're so passionate, disassembling things is the first step. Mm, And once you disassemble it, you should be able to basically modify certain pieces that will, well, change the way it functions overall. Okay. Anyway, questions done. So we're going to keep going. So often the bugs come from the library you're using that way. Yeah, that's true though. The library you use has to be trustable. You have to trust the code and the developers and the library that you're using from, right? So that's where we come back to this. How do we create those functions, those factors, right? So as a simple case scenario, keywords. These are keywords that we will use. Now, if I try to do the same thing like this and say, hey, you have if functions, you have for functions, well, they're not structured to look like this. So obviously they're going to give me these underlined errors, except class. Class is probably the only one that'll do it because you can have technically an empty class, which is weird. But it could be some sort of inheritance format you can use. But in the case scenario, you're always looking at that pattern. So functions in the same factor, I can name it anything. I'm just being super specific about this. I'm creating this function, therefore I can give it any name I want. You can make it shorter, you can make it longer. This is basically on preference, right? Which would be still kind of misleading because now notice that this function name is yellow. So is alert, okay? Now alert is built in. I haven't touched it, I haven't created it, I have nothing to do with alert, but it's still yellow because the format is a function format. Log, technically, under the official, I'm a programmer, you have to call it this way because that's why, because that separates us from the monkeys and the. Everyone's going to be a critic of the educated environment. They're like, oh, you have to call it this because it's this. It's a function. Log is a function, but it's called a method. Why? Because it exists inside of a class. End of story. But it is a function. So if I call it a function, it's because it is a function. It's a function inside of a class. So sure, you can call it a method because it's so proper, but it doesn't change that the way it works is still a function. It's a block of code, it has a name, and it exists inside of console. Console has other functions involved, warning, caution, all these kind of things that you can do. But notice these are purple. These are kind of special purpose functions, right? These are logic functions. These create the format in which if I need something to happen, in the case of if statements, if something is true, then apply the code that would be related to that truth, right? So if I make something like, here, I'll do this real quick. Normally we like to have an input. Then I'm gonna have a button over here. This is just me creating a general workspace, right? Just a little workspace for me to play around with in my browser. This is too big. There we go. All right. So button there, input there. Now, what do? We want to activate some stuff. Well, in the button, there's a nice little HTML on click piece that I can basically run whatever I want. But issue there is I'm mixing languages, so I got to use different set of quotes. Boom, button clicked. So this is an interesting case, but we're running JavaScript inside of HTML because this particular onClick is passing a function to an executable in JavaScript. But we can't really code everything we want in this space, so this is a perfect place to create a function. I don't have enough space in that tiny little onClick space, so I'm just going to create my own function, move this over, and then write the name button, click for the function I just created. Oh, let's see. Hold on. Do I need the parenthesis? I don't think I need the. Do I? Hold on. Button click's not defined. Problem. Order of operation. So Here's a case for where programs work from top to bottom. I got to define this before it actually activates. So I got to define this function above the moment I want to use it. Otherwise, it doesn't register it exists. There we go. There's ways around that. But simply the fact that I created the function later. But there's another way, actually, the on document load, but we're not going to go into that just yet. There's ways that you can kind of postpone certain code until the very end of the document loading. This is specific to JavaScript. I'm just really going over the general functional factor of how programming languages work. And every single language works in this format. It reads from line 1, line 2, line 3, line 4, and all the way down. Now, if you create something on line 17 and then you try to activate it on line 10, it's not going to work because the order of operation is the computer language did not read that. This is specific to interpretation languages, Python, JavaScript. Normally, when you compile something, there will be a case where you can go around it too. If you can create stuff at the end. I'm going to comment these out because they're going to kind of mess with my little red space here. You can use, God, what were they called when you put them at the very top? Mm, like a placeholder that says, hey, this function is going to exist at some point. Make sure you read it before you activate it, sort of thing. But here, my function needed to exist before the button click. And now from here, I can basically do the next steps and I can create something more within that factor. Now let's play with some inputs. So let's do the if statement. But first, I need an input. So in JavaScript, this is also why I love JavaScript. I can run with a GUI out the box. I don't have to do anything crazy about installing a GUI API or using PySide 6 or using XML to structure a custom document and then connecting that by. I don't have to, especially when I'm teaching it, I don't have to go through extra GUI explanations. I just say, hey, here's a document. We can use HTML because everyone's basically pretty okay with HTML. They can see the general sense of, button starts here, ends here. Maybe you don't know the general structure, but the general structure is this, right? HTML, head, body. If you kind of replicate this, you go through the process of creating that structure. Now from here, I can take that button click and I can use a keyword in get element by ID. So document is a object, something of classes we haven't talked about. I'm about to speed run the rest of it and kind of take a break. But in a general sense, we're using a document class or object that exists based on the page we're in. I'm going to use this get element by ID, which I don't have yet, which means I want to identify this input using an ID. And then I can call that user input ID here. And then now from here, I probably want to save this as var user in. And now I can test it. So now when I've saved that information into my actual variable, because this is kind of a shorthand, right? I don't want to keep doing this every time. I can easily take this whole set here and say, hey, if this is true, then I say alert, you typed yes. Else, you typed something completely different. You typed anything else. So I'm speedrunning this next section because this is just a general usage, but it should help because we're not talking about concepts now. We're talking directly about the coding process. I take the input document. Sure, I've saved it as a user in, but I'm showing you that I can still use that whole string here to activate what I'm looking for, get user input. But of course, I did forget something. I need to get what the value of this. I'm gonna have to speeding running this, so I'm gonna have to double check this. Button clicked. Okay. Oh, okay. I got it right. Yay. So dot value goes inside of the input, the user input of where I typed in yes, but I can type in anything else. Button click still works because that's basically the intro to our function. I've not done anything with this original line. I'm just gonna get it out of the way now because we don't need that. You typed anything else. Exactly. So If now becomes that test. What am I typing in? And this is a great way to create commands for your workplace. So we're going to be using this as a placeholder to basically create certain activations for our page. Sometimes I generally create like a little console, a little command prompt area where I'm just throwing in values and saying, hey, I want to search Google. So I'll type in like G and then cats, right? And then I can program the code to take this and scan what am I saying first. If I'm saying G, okay, I'm gonna go Google. And then what's the stuff that I'm Googling, right? Cats. And then it'll open up a new tab and we create our own little interface for the internet. But the key I'm gonna show you now is that I don't have to reuse large sets of code thanks to variables. Use variables as much as you can because now that value of the input that I've said I'm using twice is actually saved in the variable user in. So I don't have to reuse that. I just use the variable that contains the value and the functionality still stays true. You typed yes. You type anything else. So I didn't really, this is kind of also the case for that one individual that was asking, hey, I'm 90% on my leap code, but there's something missing. What can I do to figure it out? It could be something as simple as this. Maybe you're reusing long lines of code when you should be potentially saving it into a variable and making sure you're reusing the more effective method. That's a key. That's a key to remember. You can still achieve the exact same thing with completely different sets of code. Slightly different. But if you don't understand what the code does, then you wouldn't know that, hey, why would I type this every single time I need the value of the input? I'm just going to save it in my variable and then reuse user in anytime I need it. That's it. So less typing for you, less messy code, and basically gives you the ability to optimize the way your code is in general. So variables, which will end on this note, we haven't gone too much into functions yet, we're kind of entering this, but variables is should be fortified now. With this today's session versus what happened last time, uh, with the link that I shouldn't have clicked, should basically give you the overall idea why variables are useful and maybe should help you a little bit with the concept of mathematics to programming. Oh, hello. Where'd I go? My screen changed. There we go. So the mathematics to programming factor. Yes, in math, X, Y, Z, P, L, M, N, O, G, whatever, they all have a specific meaning. We say X is 5, therefore X is going to be equal to the number 5. Y, another variable, but then it contains another variable inside. Keep that in mind. This happens in programming very often as well. Well, you can say y, whatever the y box that I'm using, I'm going to set it as a 2x plus b. That's the math version of this. And now we've fortified functions a little bit more to see how they function similarly. We input values into a function. We run some predefined set of definitions, values, code, and then we can call it by just using the function name over and over instead of having to type this out over and over and over. It's a shortcut. It's a way for us to save useful bits of code that we can essentially use in the future just by calling the function. But then you can have some stuff, which is for the next set, is let's advance the next time we do have a session in the office hours. I'm going to show a little bit about composite functions, right? If you remember this in algebra, you're probably like, oh God, why? But this happens too. We've actually technically done this slightly within the previous case, right? There is a hidden sense of this sort of function inside of a function inside of a function situation. We just haven't been super defined and definitive in visually typing it out. But document get element ID, it takes one function, inputs it, or well, the button click function, and then calls another function in its place. We'll have to be a little bit more definitive with what a composite function would be when it comes to programming specifically. But you will see this happening. So the logic behind math to programming helps you improve your code. Now, if you don't use variables, can you still code? Yeah, but you saw what happened. We had much more messy, hard to read, extra text, unenjoyable code. So being a little bit OCD with the way that you work with your code not only will help you debug it for later, save yourself time, make sure you do it on a line by line basis. Don't type 100 lines and be like, oh, I'm gonna press run. Good luck, because you're gonna spend another times eight amount of time trying to figure out why it's not working. If you took an hour to basically code that 100 lines, now it's going to take you about 8 hours to figure out why it's not working. So take your time, be a little bit OCD if you can. And normally, the more organized you are in your head, the more organized your code's going to look. And if you're not organized in your head, you have the ability to debug yourself, not just the code, because the code is a part of yourself. And once you realize that the issues you have are, what was it? One of my tech teachers was telling me every time we get a some issue, oh, my computer doesn't work, or oh, my display doesn't turn on, all this, like we get the support service, right? We always said problem exists between keyboard and chair, Pebcus. And we use Pebcus as, hey, is that a Pebcus problem? Yeah, it's a Pebcus problem. So you have to be a little bit more empathetic and start talking to the user a little bit nicer. Hey, what do you see on the screen? Is it turned on? Did you put the power, is the power cable plugged in? It's always Pebcus, even in a developing environment. It's always Pebcus. And if it's not Pebcus, it's somebody else's code, like an API mentioned before. If you're not using a well supported and community driven set of code, an API, it's probably on their side of the problem exists between chair and keyboard, right? So when you do your own code, you're only responsible for the way that you put it together. And if you cannot do that, and if you had issues with yourself, think of that as a reason to start debugging the way you think and making it cleaner. Because not only are you going to improve your general life, like just the logical thinking process in your head, you're going to improve your code at the same time because it's one with the other. A hacker thinks or sees how other people think when they code and they exploit it. So if you can improve the way you think, you will be less exploitable to those that seek to essentially exploit you, right? Anyway, whew, thanks for joining. Appreciate it. If you haven't liked and subscribed, please do. Turn notifications on for the future. I'm probably gonna play some games now and just chill out for a little bit because man, oh man, that was fun. That was fun. Went through a bunch. So we'll be going through more in the future as well, specifically functions, and with due time, going to classes. We'll go into recursion. We'll go into, well, we're gonna be using this little space here, this little JavaScript space, and even networking, how to pull the weather off the internet with an API. All those kind of pieces we're going to start entering in. But at least for now, we've created a simple little way for you as a general user, developer, to access your own code through a simple input box. That's all that you need to start with. Create yourself a little workbench. If you have to watch it over again, watch it over again, but here is essentially the code for it. Let me see if I can gather it all in a single screen here without blurring it up for tiny code. We basically just needed this. About this right here. So this section here gives you an input where now you can start typing stuff to your computer. You can use if statements to analyze what you're typing and then activate certain things about that type. Like, do you want to search Google? That's a case for using a function called window.location. Do you want to access weather? Well, then we got to do some fetching online, networking. So a lot of pieces to play a part. We're going to expand on this workbench. And in fact, let's go ahead and update this as stream workbench. I don't need the console here. And then voila. Okay, that's not it. That's the alert. I don't need the alert. I will type. All right, here. There it is. I'm gonna turn this alert off because it's getting annoying. There we go. Stream workbench. So we'll be using this as our little workbench to continue on exploring different topics. And we still have some math to programming sets of logic to work with. But in the end, remember that it's not like you have to be a mathematician, but you can benefit greatly from it. You don't have to be a mathematician to code, but generally speaking, let's not let AI take our brains. We let calculators take our calculations. Let's bring back the calculating brain cells that have left us because of the phone having a calculator. Let's think about the operational troubleshooting factor of figuring out what I told the student, a puzzle. When you change the mathematics and say it's not math, it's a puzzle, most people start to benefit and appreciate mathematics in a different perspective. So we'll continue next time. Thanks again for joining in. Deuces. Let me find where my little stream